Welcome to Wireless Fundamentals, Session 10, Enhancing and Assessing WLAN Performance. In this section, we want to discuss some various ways to assess the WLAN RF environment. First, we have two more techniques we can use to enhance performance. This is all about balancing the load between APs and radios. RRM enhancements, including AP load balancing and band navigation, and WLAN assessment, including RF ping, 802.11 frame capture, IMC with WSM, the WSM planner, and spectrum analysis. The load balancing feature is most effective in high-density WLAN deployments. There may be 2 or 3 APs to cover a given area, but most clients might connect to the same AP. Even if the connection rate for a client is slightly lower on a different AP, clients will all have improved performance with load balancing. It is preferable for 40 clients to be distributed equally amongst 2 APs as opposed to 40 clients sharing the bandwidth and resources of a single AP. 2 load balancing modes are supported: session mode and traffic mode. Session mode is based on the number of associated client sessions. In this scenario, AP1 is supporting 6 clients, while AP2 has 1. Session mode load balancing is configured with a maximum number of sessions at 6 and the maximum session gap of 5. When client 8 sends an association request, AP1 rejects it. However, AP2 accepts it and the client receives wireless service. Traffic mode is based on a maximum traffic threshold and maximum traffic gap. When these thresholds are met, an AP will reject the client to encourage it to associate to another AP. To balance loads among APs, you add them to a load balancing group. From CLI, Load Balancing Group 1 has been created for a meeting hall. A set of APs were then added to this group. Once you have created a load balancing group, you can configure load balancing parameters. AC global parameters are used to configure traffic or session-based load balancing. From the CLI's global context, enter WLAN RRM context. The load balancing mode is set to session mode. Load balancing will begin when the AP in the group has at least 15 clients and a gap or difference of at least 5 clients with other APs in the group. In other words, some other AP in the group has at least 5 fewer clients. The RSSI threshold sets the acceptable differential in client signal strength for load balancing to occur. An AP considers a client whose RSSI is lower than the load balancing RSSI threshold as not detected. If only one AP can detect the client, the AP increases the access probability for the client, even if it is overloaded. The default is 25. The other setting you see here is the maximum denial count of client association requests. If the times that a client has been denied reach the specified maximum times, the AP considers that the client is unable to associate with any other AP and accepts the association request from the client. The default equals 10. Here's another example for load balancing using traffic-based load balancing. APs in the group will begin to use the feature when their traffic load is 40%, and gap in load for other APs in the group is at least 20%. The other values are the same as for session-based load balancing. To see members of a load balancing group, use the command display WLAN load balance group 1. To see information about AP neighbors for a particular group member, use display WLAN load balance neighbor list AP AP1. To see information about clients attached to a load balancing group, use Display WLAN Load Balance Neighbor List Client MAC Address. Many environments simply have more 2.4 GHz clients. Also, while some clients have both 2.4 and 5 GHz radios, they may tend to favor the 2.4 GHz radio. Each AP's 2.4 GHz radio can get overloaded with clients, while the 5 GHz radio sits largely idle. This is not an efficient use of resources. The band navigation feature seeks to mitigate this issue. When enabled, clients that only support 5 GHz, of course, continue to connect to the 5 GHz radio. It is their only option. A dual band client may transmit connection requests on both the 2.4 and 5 GHz bands. The 5 GHz radio will immediately respond, while the 2.4 GHz radio will not. These clients will therefore tend to connect to the 5 GHz radio. Clients that lack 5 GHz capability have no choice. They must connect at 2.4 GHz. The AP will reject the client a few times as it determines that indeed this client has no choice, and then allows the client to connect. Before encouraging dual band clients to the 5 GHz radio, the AP checks client RSSI values. If the 5 GHz RSSI value is too low for the client, it will be allowed to connect at 2.4 GHz. If the 5 GHz client count reaches an upper limit, and the gap between 5 and 2.4 GHz clients reaches an upper limit, the AP denies 5 GHz associations and allows clients to connect at 2.4 GHz. Also, if a client has been denied a 5 GHz connection for a configurable number of times, the 5 GHz connection is accepted. First, enter the WLAN RRM configuration context, and then enable band navigation. In this example, the feature activates when there are at least 10 client sessions connected and a gap between 2.4 and 5 GHz of at least 5 sessions. The aforementioned RSSI threshold is set to 15, and the aging time is set to 180. With global parameters now set, you can enable the feature on the APs or AP groups of your choice. There is a special RF ping function for WLAN clients. This feature reveals connection performance information between an AP and associated clients. This includes signal strength, packet retransmission attempts, and round-trip time or RTT. From the GUI, navigate to Summary, Client, to enter the client page, and then choose the Link Test Information tab. Then click the client name to view test information. Or, from the user view of the CLI, enter WLAN Link Test Client MAC address. For WLAN systems, it can be difficult to see signal interference or packet collisions by using the CLI debugging feature or display commands. Another option for troubleshooting is to perform packet captures. You could configure a laptop with software such as Wireshark, travel to the on-site location, and capture packets with your laptop. However, in some cases, it might not be practical to fly all the way to, say, Nantucket for diagnostics. Instead, you can configure an AP as a packet sniffer. It will capture and record wireless packets and place them in a .dmp file for analysis. In the figure, the center AP has been configured for frame capture. It is centrally located near the other APs and some clients. An analysis of the .dmp file might help you determine why a client can't associate, or perhaps even discover a rogue access point. There are several software products that can gather RF information, such as signal strength and signal-to-noise ratio. It color codes this information superimposed on a floor plan. These are called heat maps. Here's an example of a site survey performed for an outdoor parking area. There is a light blue color that indicates areas with a very strong signal, a yellow area with a fairly weak signal, and some large green areas with a good signal. You can use this information to decide where to add or rearrange APs to optimize coverage. The Wireless Services Manager, or WSM, is a software module for HP IMC management platform, providing unified management of wired and wireless networks. The APs gather RF data from the live environment and pass that information to the AC. The IMC WSM gathers this information and displays it for you. You can see the hot areas of strong signal strength near the APs and weaker areas of signal strength as you move away from an AP. This is a very powerful management tool, especially when coupled with user feedback. You can correlate the user experience with heat map information to gain deeper insight into the WLAN. It becomes more visually obvious where you might need to add APs. The WSM can also track client connection history and statistics to ease the troubleshooting process. You can use the WSM's RF Planner feature to plan a new AP deployment. This software draws on a comprehensive database of HP's APs, sensors, and antennas, as well as third-party client cards, APs, and antennas. During a planning session, you draw a border around the area to be planned. Then you select a 2.4 or 5 GHz technology and an AP model. You also specify your required minimum signal strength and expected number of clients and per-user bandwidth requirements. You can also draw in walls and other obstacles to increase the planner's awareness of your actual environment. It will then provide an estimate of the number of APs required for the deployment and place APs in a grid pattern on the floor plan. A spectrum analyzer measures the strength of a signal related to its frequency over time. Some RF engineers have purchased separate spectrum analyzers or software and adapters that can be installed on a laptop. This gear can help you to visualize RF energy in real time and analyze the output to determine sources of interference. HP Unified WLAN solutions include spectral analysis capabilities integrated into the solution. This Spectrum Guard feature can intelligently analyze the RF environment to help you mitigate sources of interference. Spectrum analysis delivers the following functions. Identifies 12 types of interference, including microwave ovens, Bluetooth devices, fixed frequency video cameras, cordless phones, game consoles, and more. Interference device reports are provided. It calculates the number of interferences on each channel and average and worst channel quality, and provides channel quality reports. With RRM collaboration enabled, if the detected channel quality is lower than the threshold, the AC automatically adjusts the working channel upon detecting a channel with a higher quality. Administrators can view the interference information on the AC or view real-time spectrum analysis data on the NMS to locate and remove the interference. We've come a long way, and you have learned many concepts and real-world deployment and optimization techniques. A well-deployed, optimized WLAN provides at least one major advantage over wired Ethernet connectivity. It is the freedom to move about the office while remaining connected. In Session 11, you will gain a more in-depth understanding of how separate APs provide a uniform blanket of connectivity for clients. You'll see how clients can seamlessly roam from AP to AP, even if those APs are associated with different access controllers.